Now the sixth example for friction clutch. Now a machine is driven from a constant speed shaft, uniform speed, rotating at a speed of 300 revolutions per minute by means of a friction clutch. Now the moment of inertia of the rotating parts of the machine is 4.7 kg meter squared. So that is the second moment of mass, or the moment of inertia. So the clutch is of the disc type, both sides of the disc being effective in producing driving friction. Now the external and internal diameters, so usually they give us diameter, so it is better for you to take note, okay, because sometimes you might make mistakes. You might consider this as a radius, where you straight away substitute these values here into the formula. Okay, so you should take note of this. Okay, so of the discs are respectively 200 millimeter and 125 millimeter. So the external diameter, and this is the internal diameter. So divided by 2 divided by 1000, so this should be 0.1 meter. And this one divided by 2, it becomes 67.5. So divided by 1000, so you have 0.0675 meter. So the actual pressure applied, okay, the actual pressure applied to the disc is 70 kilonewton per meter square. Now assume that this pressure is uniformly distributed, uniform pressure, and the coefficient of friction is 0.25. If when the machine is at rest, okay, initially, the clutch is then suddenly engaged, what is the length of time that is required for the machine to attain its full speed? Okay, so remember here, what is given is, first thing here is the speed, okay, then the moment of inertia, or the second moment of mass, this type, a single disc with both sides effective, and then you have this as external diameter, this as the internal diameter, the pressure is given, the coefficient of friction is given. So the clutch wants us to find, is initially at rest here, to find the length of time, okay, to attain full speed. So now, these are the given data. So this is the omega against time graph. This time I show you the omega against time graph for the machine, okay, for the machine. So they have given us, okay, a constant speed of 300 RPM. So this should be your final speed, 31.42. When you convert this from RPM, revolutions per minute, to radians per second, you must multiply by 2 pi and then divided by 60. This is the final speed, the full speed, which the shaft or the machine achieved. Now, initially is at rest. The question says initially the machine is at rest. So that is at 0 radians per second. So based on the omega against time graph here, you will be able to draw a straight line. So the slope of straight line on an omega against time graph is usually referring to the angular acceleration, the slope here of the line. So which is equals to alpha. And at the same time, if you want to find the angular displacement, okay, for the machine, so you can use the area of this diagram here, okay, to find out the angular displacement. And then this is the time axis. So this is the period to which the machine has gone through in order to reach this speed. Okay, so based on uniform pressure theory, the question says the pressure distributed is uniform. Okay, so you have the torque transmitted formula. So this is a simplified formula, yeah. This is a simplified formula. Now, if you put the pressure, okay, which is equals to force over area of pi r1 square minus r2 square, you get the whole formula as 2 over 3 mu W. Okay, mu W, R1 cube minus R2 cube over R1 square minus R2 times N. Okay, so this pressure here. Okay, so because the pressure are given, so straight away we can apply this formula. Otherwise, we use the original formula. Okay, so you have the torque transmitted, that is 55.4 Newton meter. Then based on Newton's second law, remember for rotating objects, you have T equals to the product of the moment of inertia and the angular acceleration. From this, you will be able to find out the angular acceleration alpha. So you have alpha manipulating this equation, changing alpha to be the subject. So you will have T over I. So you have 55.4 divided by 4.7, which is given in the question. So you will be able to find out the angular acceleration of the machine or the clutch. So it's 11.79 radians per second. Then the time required, so you must remember how to define acceleration or angular acceleration. By looking at this graph here, basically I think you would know that to find a slope, okay, you have to take the vertical distance divided by the horizontal distance of a speed against time graph. Okay, so you have this. So this is actually the slope, and this formula here can be found by finding the slope of this line. Okay, so initially at rest, so your omega 1 should be 0. Okay, alpha, you have found the alpha, and then the omega 2 is actually based on this 300 RPM. Convert these to radians per second, so you have it here. I've put it in the diagram, which is the 1.42 radians per second. Okay, so omega 1 here is 0 because they say the machine is initially at rest. Okay, so from this you will be able to find out the last part of the question is 2.66 seconds. So that is the time required to attain full speed from 0 radians per second to 31.42 radians per second. Okay, thank you for this slide. Okay, stay safe, everybody.